and welcome to Busy Little Minds. I'm back with another video, and I'm pleased to announce that this video is the next episode in the Basic Physics series I made public last week. Today's episode is a short one, and it's going to be about gravity, friction, and other everyday forces. So without any further ado, let's go! Gravity and friction are some of the most important concepts in physics, and you absolutely must know them to go on. Gravity is the attractive force between objects with mass. Gravity is quite easy to demonstrate in everyday life because we see it happening everywhere. If you throw something upwards, then the object eventually comes down and hits the ground due to the force of gravity, which the Earth is exerting on the object. We are also exerting force on the planet, but since our mass is so minuscule compared to the force of the planet, Earth doesn't change its motion because of us. Gravity varies with mass, and so the gravity on Jupiter is obviously much greater than Earth's. Gravity on very large scales is much more complex than just the simple throwing an object in the air and it returning to the Earth. Gravity bends space-time, the very fabric of the universe, but we can get into that later. Friction is the force that opposes movement between touching surfaces and always acts against the direction of motion. Friction is not as obvious as gravity, but it definitely can be demonstrated. One simple example is when you rub your hands together. The friction, or resistance, that is generated causes your hand molecules to speed up, and the speeding up results in heat. There are actually 4 types of friction, which we'll go over one by one. The first type of friction is air resistance. Air resistance. The more surface area an object has, the more air friction is acting on it. If you drop a ball from the sky, it takes no time in falling to the ground. But if you drop a paper from the sky, it falls quite slowly. Why? It's because of air resistance. Not all of the surface area of the ball is exposed to the air. Just a small area is exposed to the air below the ball, which contributes to a smaller surface area, which equals less friction. So the ball falls very quickly. The paper, on the other hand, has a lot of surface area exposed to the air below it, so there is more air resistance and the paper falls slowly. Static friction is the force of friction between surfaces not in motion. Static friction can be described as friction between 2 rough, stationary objects, such as a tire and the pavement. Although they are both stationary, there is still friction between them because they are so rough. Sliding friction is the force of friction that affects objects in motion. It's also known as kinetic friction. Sliding friction is the reason it is so hard to push a couch or large object across a room. The mass and roughness of the object contributes to its sliding friction. Rolling friction is the friction between surfaces when a wheel rolls freely over a surface. Rolling friction can be easily exemplified. Cars are subjected to rolling friction when the tires move. Carts and stores are subjected to rolling frictions when they are moved around. Rolling friction is significantly less than sliding friction, which is why it is easier to move objects when they have wheels. Now, let's contemplate terminal velocity. Terminal velocity is the speed at which the force of gravity equals air resistance. Terminal velocity is essentially free fall, because air resistance pushes you up and gravity pulls you down. If an object is at terminal velocity, it is moving neither up nor down, resulting in a free fall. When you jump up, for a fraction of a second, you are at terminal velocity, but eventually you come back to the ground. Similarly, a skydiver is at terminal velocity for a while, before gravity wins the battle. The definition of a magnet is another thing that we should cover. A magnet is a material that is attracted to iron, steel, and other magnets. Magnets are everywhere. You probably have one on your refrigerator right now. In fact, even the Earth is a giant magnet. A magnet has 2 poles, north and south. And when a magnet detects another magnet, 2 things can happen. If both magnets are facing each other with like poles, then they repel each other. If both magnets are facing each other with unlike poles, then they attract. We'll learn more about the properties of magnets in another episode. Electric force is the attractive force between opposite charges and the repulsive force between like charges. Electric force is the principle that I just introduced in magnets. Like poles repel, unlike poles attract. Centripetal force is the force that causes objects to follow a curved or circular path and is directed inwards towards the center of rotation. To explain this concept, let's use a mini thought experiment. Imagine that you just got a yo-yo and you are swinging it around above your head. What shape does the yo-yo swing around in? If you observe carefully, the yo-yo's orbit takes the shape of a circle. This is because of centripetal force. When you let go of the yo-yo, it breaks its orbit and flies in a straight path. Centripetal force is also the force that keeps the planets in our solar system in motion around the sun. They cannot escape, and they also don't fly inwards towards the sun. Buoyant force is the force that keeps objects floating in a liquid. Buoyant force is equal to weight of water displaced. Buoyant force is also called Archimedes' principle because a scientist named Archimedes discovered it. Let's say that you have a glass of water that's filled to the brim. If you place an object in the glass, some water overflows. The amount of water that overflows is the buoyant force. If you enjoyed this video, give it a like. If you want to see more videos like this, subscribe. Thanks for watching!